Okay, so we've seen that sodium reacts and will dissolve into water itself. Magnesium does not, or at least not easily, into water, but does react quite readily with 1 molar HCl, 1 molar hydrochloric acid. Now we're going to look at two other metals. We're going to look at zinc, and this version of zinc is called mossy zinc because of the form it looks in, but it's zinc metal. And we're going to look at copper, and the copper is actually we have BBs that you would get for a BB gun, and they're actually made of steel, but they're copper coated, so we'll be able to see if the copper reacts because the copper is coating the outside of them. So we're going to try those also in water and HCl and see what happens. Okay, so we're going to start with zinc. First, we're going to add some zinc into water. So we can take some mossy zinc and put it in there. And it does nothing. Zoom in on that a little bit. And so the zinc is clearly not reacting. Okay, so now let's do zinc again and look at it in 1 molar HCl. So we'll go over to our HCl beaker. We'll add the zinc into that. And so that is reacting. That is starting to bubble. You can see a plume of bubbles coming up. And so it's emanating a gas just like the magnesium did in HCl. It's reacting more slowly than the magnesium did, but it clearly is reacting. So while we're watching that, let's do another test. This is the zinc reacting in 1 molar HCl, and so you can see the bubbles coming up from the pieces of the zinc. Now what we're going to do is we're going to do the same reaction, we're going to do it in 6 molar HCl. So the same reactant, hydrochloric acid, but 6 times more concentrated. So what we're going to do is we're going to add some to it, some of the zinc to 6 molar HCl, which is over in this beaker over here. So this is the 6 molar HCl. And what we see is it reacts much more quickly. A little clearer if we turn it around. So you can see there that the same reaction is happening, but much, much, much faster. And that happens with a lot of chemical reactions. That the more concentrated the reagents are, the faster the reaction happens. So with the slow reacting HCl, it takes a while, but eventually all of the zinc does dissolve. So HCl can dissolve magnesium, and it can dissolve zinc. Next what we'll do is we're going to look at copper. And to do that, we're going to use our copper-coated BBs. So let's go ahead and add our copper sample to the 1 molar HCl. It's a little hard to tell where they even are. There we go, roll them to the front there. And so they are clearly not doing anything. So HCl is not a strong enough reagent to dissolve the copper. And if you leave it there for quite a long time, it still won't. They'll basically, the copper might get a little cleaner looking, but it basically is not going to react. So the next thing we'll try is we'll try to do this using nitric acid. And for reasons you'll see in a moment, that is something we don't do out in the open, but we do that in a fume hood. So we're going to move over to the fume hood for our next experiment. Alright, we've moved to the fume hood, and we can see that our copper-coated BBs are still not reacting in the 1 molar HCl. And now what we're going to do is we're going to move over and try 1 molar nitric acid. Nitric acid is a different kind of acid than HCl in that it's considered to be an oxidizing acid. So it acts both as an acid and as an oxidizing agent. So let's go ahead and try this. So we'll put in the same number of BBs, 5 BBs. Let's move those so they're forward. After a couple minutes, we can see that there's a red tinge on the bottom of the BBs as if they're reacting. but it's reacting really quite slowly. So what we're going to do is we're going to move over and do more concentrated nitric acid. Okay, so after about 15 minutes, the copper-coated BBs have reacted a little bit in the 1 molar nitric acid. You can see the brown tinge on the bottom there, which is one of the products of the reaction. But because it's so slow, what we're going to do is we're going to move over to a stronger concentration of nitric acid. We're going to look at 6 molar nitric acid and add some BBs into it. Move those over towards the front. And we'll see that those react quite quickly. And so the copper did not react in HCl, it reacted slowly in 1 molar nitric acid. Now it's reacting quite quickly in 6 molar nitric acid. And you can see the brown color of the gas that's forming. And that's one of the products of the reaction. So close up you can clearly see the stream of gas coming off, and you can also tell how reddish brown the gas is. So what we've seen is that in terms of the strength of the reagent for dissolving metals, water was the weakest, hydrochloric acid was the next strongest, and nitric acid was the strongest. And for both of the acids, the stronger the concentration, the faster the reaction occurs.